The linear correlation coefficient is denoted by R, and it measures the strength of the linear association between two variables. The strength of R is measured between -1 and +1, meaning it can go no lower than -1 and no higher than +1. The closer to -1 you are, the stronger the negative linear correlation. The closer to +1 you are, the stronger the positive linear correlation. And the closer you are to 0, the weaker the linear correlation is. Essentially, you're saying that there is no linear correlation. So what I'm going to do here is just look at some graphs and their R values and just show some different aspects of linear correlation, just so they look like graphically. So we're going to start off with positive linear correlations. So we have this one here, and you see the blue lines or blue dots going up, and it looks fairly linear, fairly like a straight line here, a little bit of a bump here, a little bump there. And you can see that the R value is 0.996. So this is a very strong positive linear correlation. It's almost like a straight line. It's not perfect, which is why R isn't exactly 1, but it's pretty darn close. The next one we have here, we can see the linear correlation. The lines are definitely not in a straight line, but they have some waves to it, just like this. But you can see that it starts low and it's going up in a fairly straight manner-ish. It's kind of going up like that. So this has a good positive linear correlation, 0.856. So again, it's definitely not a straight line, but you can see that it's kind of has a positive increase as we go along, kind of straight line-ish. Then here we have something that we label as a poor positive linear correlation, 0.449. And you can see that the line or the dots are all over the place, but you can see it kind of starts off low and works its way up. So it's kind of, I won't even say kind of linear-ish, but you can see it's definitely kind of positive. It's kind of going up, even though you have some stuff that's low and high. It's kind of going up. So this has a really poor positive linear correlation because it's kind of just scattered all over the place, but it's starting at a low point and going to a high point. And the terms I use, strong positive, good positive, poor positive, they're just relative terms. There is no actual set terminology to use. It's just what I use, just to describe what I see when I'm looking at this. Next, we're going to look at some negative linear correlation graphs. So we're going to start off with something that's a strong negative correlation, negative 0.982, and you can see this graph starts up high and then goes down, kind of in a straight line, but really not an exact line. You can see it kind of bumps a little bit here, bumps a little bit there, but it's still mostly a straight line. But this is going down, so we call this a negative linear correlation. It's strong because it's kind of like a straight line. Next we have is a good negative linear correlation, negative 0.912. Again, the line or the dots are definitely going down, and it's definitely going from high to low, but they're not all together. They're not all in a straight line, but it's definitely negative as it goes down. So it's a little bit spread out, not a lot spread out, but a decently amount spread out. And then we have, again, a poor negative linear correlation. Again, it kind of starts off high and it kind of goes down low. So it's definitely negative. But again, it's so widely spread out, so all over the place, there's not really much of a linear correlation, which is why it's a negative 0.542. Definitely going down, but it's so spread, there's not much of a strong correlation with it. Now again, I use strong, good, and poor as just relative terms to describe it. You can use whatever terms you want. But there's also one last one, and that is no linear correlation. And you can see here that while the R value is negative 0.113, it's really all over the place. It's hard to tell that it really starts up high and kind of goes down low. It's so widely all over the place. It's really just scattered everywhere. That's really hard to see that there's even any correlation whatsoever, even if it's just extremely weak, being 0.113, negative 0.113. But when you do the math, it comes out as a negative, so it's an extremely weak negative linear correlation. But I would like to call it more along the lines of no linear correlation, because it's just all over the place. But that's how you would read and understand, what the linear correlation coefficient R is trying to say to you when you look at it specifically graphically, because it's a little bit easier to see it that way.